discussed yesterday, there is one problem. We discussed that go gauges are designed at maximum battery limit condition, and the no go gauges are designed for minimum battery limit condition. Means the dimension of go gauge should be the maximum battery limit, and the dimension of no go gauge is the minimum battery limit. But the problem is that we cannot manufacture anything exact. That's what the whole methodology is basically standing on, that we cannot manufacture anything exact. Everywhere there will be tolerances. So there will be tolerances on the gauges also. There will be tolerances on gauges also. So tolerance on gauge is called necessary evil. Necessary evil. Why necessary evil? We don't want it, but without tolerances we cannot produce it. Okay? So when we have to get tolerance on the gauges, this gauge tolerance we will give 1/10 of 1 tolerance. Suppose we are, nobody should write anything in the notebook. First of all here, because here is most important in this section. Suppose we are designing go gauges, or you can say plug gauges. So tolerance of hole is the work tolerance. For the plug gauges, gauge tolerance is equals to 1/10 of hole tolerance. But when we are designing the ring gauges, gauge tolerance is 1/10 of shaft tolerance. Correct, na? So for plug gauges, hole tolerance is nothing but the work tolerance. For the ring gauges, shaft tolerance is nothing but the work tolerance. Okay, na? So second statement of Taylor pass, go gauges are used to check size as well as shape and has to be in the full form. So let us say L is the length of hole and X is the length of gauge. X will be greater than X because it has to cover the entire working length of the hole, because it has to check size as well as shape. So go gauge is moving in the entire working length of the hole or shaft. Because shape means if the hole is slightly tapered, it will be little अटक जाएगा. वाला विलेज वाला दिनों में कुछ ना. So that you understand that. So to check size as well as shape. So since the go gauge is moving in and out, every time for every checkup, there will be some wear on the go gauge. Correct, na? There will be some wear on the go gauge, and due to the wear, imagine the plug gauge. The size of plug gauge will keep on decreasing, and when the size decreases below a certain value, go gauge is gone. We cannot use it for the measurement. Okay, na? So to increase the life of go gauge, we provide wear allowance only on go gauge, because the wear is taking place on the go gauge every time it is moving in and out. So wear is taking place on the go gauge, and this wear allowance is 1/10 of gauge tolerance, or in other words 1/100 of work tolerance. Why we are providing wear allowance on the go gauge? To increase the life of go gauge, because every time it is moving in and out of the hole, so there will be some wear. Got it, na? This thing everybody is clear? Now the question comes, we have to provide the tolerances. So once again, everybody will look at the board. Let us say this is our zero line. and let us say this is your full tolerance. So the plug gauges will be designed here. So the plug gauges will be designed here. This is hole. And let us say this is your shaft. So the ring gauges will be designed here. So for the plug gauges, this is the work tolerance, and for the ring gauges come front. Ring gauges, this is the work tolerance. Come with the front and all of you. So for ring gauges, this is the work tolerance. For plug gauges, this is the work tolerance. For ring gauges, this is the work tolerance. Okay, na? Correct, na? Once again, for plug gauges, this is the work tolerance. Ring gauges, this is the work tolerance. Okay? So, there are three types of gauges. There are three types of gauges. First type of gauge is the workshop gauge. First type of gauge is workshop gauge. It is not gauge. Some faculties also pronounce gauge. No, it's a gauge. Pronunciation should be correct. Eulers, not Euler. Eulers. This is gauge, not gauge. Okay, now pronunciation should be correct. Von Karman, not von Karman. Okay, then the impression, suppose we are speaking impression will be correct at least. So gauge. First type of gauge is the workshop gauge, or the gauge for the workshop department. Gauge for workshop department. The philosophy of workshop department is we will not produce anything defective. Philosophy of workshop department is that we will not produce anything defective. So due to that philosophy, tolerance on gauges will be towards work tolerance. As we discussed yesterday, the go gauge will be designed here and the no go gauge will be designed here. Okay, na? Similarly for plug ring gauge, go will be designed here, no go will be designed here, and we have to provide tolerance on the gauges, otherwise we cannot manufacture it. So workshop gauge says we will not produce anything defective. So the tolerance will be towards work tolerance. So this is the tolerance of no go gauge, and this is the tolerance of go gauge. See, this is the wear allowance. Why we give the wear allowance to go gauge? Increase the life, because every time go gauge is moving in and out, so there will be wear on the go gauge. So we have to give the wear allowance. But remember that the wear allowance is 100 times of the work tolerance. So when the work tolerance is almost 0.1, then the wear allowance will be 0.001 microns. It will be very difficult to provide. Is it enough? 1 micron is very insignificant. So when the work tolerance is less than 0.1 millimeter, we don't give any work tolerance. We don't give any wear allowance. Jen says 0.09. That is old concept. That when work tolerance is less than 0.09, we will not provide any wear allowance. But actually, IC Gupta or the updated version is that when the work tolerance is less than 0.1, we don't provide any beer allowance. Correct? So let us say this work tolerance is X. This will be X by 10. This also will be X by 10. And this will be X by 100. Beer allowance will be X by 100. And same thing we can do it here for the ring. This is go. And this is not go. Suppose this is Y. This will be Y by 10. This will be Y by 10. And this will be Y by 100. Is that everybody is following that, no? Because the philosophy of the workshop department is that we will not produce anything defective. Philosophy of the workshop department is that we will not produce anything defective. So due to this philosophy, tolerances are towards the work tolerance. And depending upon the work tolerance, we will give beer allowance or no. And what is the significance of tolerances? Our gauge can be anywhere in this range. That is the meaning, huh? What is the meaning of tolerance of hole? Our hole may appear anywhere in this range. Because tolerances refers to a group. Tolerances refers to a group, not the individual component. So it can be anywhere in this range hole. Similarly, to check this type of hole, our not go gauge, the dimension can be anywhere in this range. This is the minimum dimension and this is the maximum dimension. For go gauge, this is the minimum dimension, that is the maximum dimension. Is that all right now? Now, what is the meaning of this sentence? That we will not produce anything defective. Suppose everybody is able to follow up to this point now. Suppose my go gauge can appear anywhere in this range. Suppose this is the size of go gauge. Because it's a probability that our size of go gauge can be anywhere in this range. So let us say this is the size of go gauge. And when this size of hole approaches this go gauge, this is the size of go gauge, it can be anywhere in this range. That is the meaning of tolerance. So suppose the size of go gauge is here, and when this size of hole approaches this go gauge, this hole is well within the tolerances. Is it not? This hole is well within the tolerances, so it should be accepted. But because the go gauge is slightly higher than this, go gauge will not go inside the hole. So, according to the go gauge, the hole is undersized. According to the go gauge, hole is undersized, but the hole is correct. Same thing will happen on the no go gauge side. Let us say this is the size of non go gauge, because that can appear anywhere in this range, size of logo. And let us say this size of hole appears to the no go gauge. No go gauge will enter into the hole. So according to the go gauge, the hole is oversized, but the hole is well within the tolerance. So by adopting the workshop gauges, although we are not accepting any hole beyond the tolerance, but some of the good parts will be treated as bad parts. By accepting the workshop gauges, some of the good parts, these good parts, will be treated as bad parts. That is why it's an evil. Gauge tolerance is necessary evil. That's why it's evil. You take your time. I will dictate first. There should be sufficient space here. You make this diagram here like this. I will some diagram more diagram will draw. I will dictate. Then again I will come back. Understood why it's a leading? Take your time, okay na? Understanding, if there is anything, again I will explain. Any question anybody is having? You have questions? Extreme cases means? No, you will not say extreme cases, you can say the holes that are appearing close to the tolerances. Close to the tolerances limits, they will be rejected by the gauges. Okay na? Santosh, you have something? You want to ask something? You want to ask? Yeah. For? Here the tolerance will be on the nominal size. Third plug gauge or ring gauges, that tolerance we will provide on the nominal size. Okay, na? If you are a practicing engineer in that area, some guidelines are given in IC Gupta. Okay, na? How basically you have to IC Gupta gives the guidelines in that. Okay, you are practicing this thing. I will tell you the ordinance factory they use something. Okay, I will tell you.
What is nominal size?
What is that?
Nominal size.
I will tell you that. Actually, nominal size here or here you are talking about?
Yes.
See, the nominal size when we say na, it is the nearest round number as per the standard. That is the nominal size. Okay, na? Especially when we are talking about the ball and shaft system. Nominal size is the nearest round number as per the standard. That is the definition of nominal size. But nominal dia in thread is slightly different. I got confused basically. There are 5 parameters. One of them is the nominal diameter. Your definition I will tell you, but design you will discuss these things in detail. Shall we write now? Everybody ready? I am thinking date 2013. As per the pattern, one question is expected to appear from this section. Whatever I am discussing today. See, last year I told ES, everything same, exactly same. They see reciprocating compressor. Also I told you the long back. The question was there in the exam. Or whatever you are underlining, you will get most of the question and objective from that section. Okay, na? It can be predicted, especially ES. Gate also I am thinking, one question will appear from this section in GATE 2030 because it did not appear 2 years. So I think this year it is going to appear. Okay, so please be little careful. And in GATE, you know what happens? There are certain difficult problems. If you can hit them, you will be able, because easy problem anyway everybody is doing. Some difficult problem comes. This year only 2-3 difficult problems were there. So somebody did that, they don't have a ranks. Of course, you have to do the easy problems also. Okay, no? Easy problem also you have to do. Okay, back down slowly. Since it is not possible to produce, anything exact. So go and no go gauge is also. So go and no go gauge is also cannot be produced exact sizes. Cannot be produced in exact size. Full stop. So we have to provide tolerance on the gauges also. So we have to provide tolerance on the gauges also. Tolerance on the gauges also. Full stop. Since every time go gauge is moving inside and outside. Go gauge is moving inside and outside. So there will be some wear on the go gauge. So there will be some wear on the go gauge. Full stop. When the size of go plug gauge, decreases below a certain value, gauge cannot be used for inspection. Gauge cannot be used for inspection. Because it will not be accurate. Next sentence underline. So to increase the life of go gauge, we wear allowance. We provide wear allowance. We provide wear allowance. So wear allowance will not be provided on the no gauge. It will be provided only on the go gauge. Okay? Full stop. When the work tolerance is less than 0.1 millimeter, when the work tolerance is less than 0.1 millimeter, we don't provide any wear allowance. We don't provide any wear allowance. Please stop. There are three types of gauges. There are three types of gauges. Number one, workshop gauge. Heading, workshop gauge. Workshop gauge. Write down this. Philosophy of workshop department is that we will not produce anything defective. We will not produce anything defective. Full stop. Due to this philosophy, tolerance on the gauges are provided towards the work tolerance. Provided towards the work tolerance.
So why there is no wear on the no-go gauge?
Because it is not moving inside outside, na?
So, but there are some holes which are above the tolerance also. There are some.
Tolerance is when the no-go gauge or little bit inside, go over, throw it away. So it is primarily outside only. But go gauge has to go through and through because it has to change the shape also. That's why there will be wear. No gauge there will not be wear because it is going only outside. But every time go gauge is moving, so there will be wear. Next,
corners में corners of the
no gauge. No. Generally corners will not be sharp. It will be like hemispherical, so there will not be anything. We will discuss the material, then we will talk about. Okay. Next sentence, underline. As it can be observed from the diagram, that by adopting these types of gauges, some of the good parts will be treated as bad parts. Some of the good parts will be treated as bad parts. Whatever you have written in workshop gauge, read it once. Whatever you have written in workshop gauge. Cold water we can on so that you can take cold water. Where is the water today? सही है? Okay? Correct? So first type of gauge is the workshop gauge, in which we provide gauge tolerance towards the work tolerance. Second, everybody look at the board. Second type of gauge is the inspection gauges. Inspection department. Gauges for the inspection department. Because when the product is produced, it goes to the inspection department. Anyway, this one, industrial is a very beautiful subject. You will discuss at the last. Then you integrate everything, you will be happy. Oh, I know so much mechanical. You will discuss this in December only. Then everything is lined up. That is the last topic to discuss. Only after that, you will discuss only compressible flow, those ones. Because generally people get taxed because of that. It is only for ES and IS, not for gate. Gate head, it is not in the course. So, philosophy of inspection department. What is the philosophy? Workshop department. What is the philosophy? We will not produce anything defective. Inspection department says. You will not give anything. Inspection department says there is already lot of effort that has been taken to make the product. So, no good part has to be rejected. Workshop department says we will not produce bad parts, but there will be tolerances. Some good parts you are rejecting. Inspection department says lot of effort, then machine material, lot of things has gone to make this product. So good parts should not be rejected. Understand? So due to this philosophy, the tolerance on the gauges will be away from the work tolerance. So this is the workshop, and if you see inspection, the tolerances will be away from the work tolerance. Like this. This is go, this is not go. This is go, this is not go. Tolerance will be away from the work tolerance. So we can see here, whatever holes that are coming in this range are accepted. Everything is accepted. So we are not rejecting any good part. That is a tolerance on the go gauge, tolerance on the no gauge. So whatever holes that are coming in this range, that is within the tolerances, will be accepted by the gauging system. But the meaning of tolerance is the go gauge size can be this, because go gauge can appear anywhere in this range. Go gauge size can be this. Now, when this size of hole is approaching the no go gauge, this size of hole is approaching the no go gauge will not enter into the hole. According to the no go gauge, the part is correct. But technically speaking, the part should be rejected because it is coming beyond the tolerance zone. Similarly, on this side, go gauge size can be this. And when this size of hole approaches the go gauge will enter into the hole. So according to the go gauge, the part is correct. But technically speaking, this part must be rejected. So by adopting inspection type gauges, some of these bad parts will be treated as good parts. Both here and the ring. Workshop gauges, some of the good parts will be treated as bad part. For inspection time, some of the bad parts will be treated as good parts. Why? Because there is a tolerance on the gauges. That's why it is called necessary evil. It's an evil. Because we are not able to filter properly. Now see the next sentence. Since these inspection gauges are already slightly inaccurate. This is an inaccuracy, because we are accepting the bad parts and good parts. We are accepting bad parts and good parts, so it's inaccuracy, na? That's the reason we don't provide any wear allowance on the inspection gauges, because the gauges are already slightly inaccurate. We don't provide any wear allowance on the inspection type of gauges. Only workshop type of gauges we will provide. Any question? Fun to चीज है? हाँ. Make it. I will discuss ours. Make it. Any question anybody is having now? Question है? Correct ना? Anyway, read 2-3 times. Then you will understand this thing. Little complicated. I also understand, frankly speaking. This particular section up to half an hour, till half an hour, from wherever we start in methodology. Frankly speaking, I assign it as one of the most difficult section in mechanical engineering, but I have made it as easy as possible for you. Another proportion between the metal format. Same. See, one thing I will do. This lecture video I will make available free to all of you. Okay, na? Because I will request on the desktop I will put it tomorrow. And those who want, they can take it, because the topic is little complicated. So 2-3 times if you see, I think everything will get into your mind. Okay? And I am planning basically, because the topic is little complicated, I will try to put on the YouTube also. Okay? But here you can take it tomorrow. This lecture, today's lecture everybody can take. Okay? क्या हो गया था? जो सवाल है write down inspection type gauges. Second type of gauges, inspection type. Write down philosophy of inspection department is that already lot of effort has been taken to make the product. So, no good part must be rejected. So, no good part must be rejected. No good part must be rejected. So, hence the tolerance on the gauges. So, the tolerance on the gauges is away from the work tolerance. But it can be seen from the diagram. That by adopting these types of gauges, some of the bad parts will be treated as good parts. Some of the bad parts will be treated as good parts. Next sentence, underline. Since the inspection gauges are already inaccurate, so no wear allowances are provided on them. So no wear allowances are provided on them. So no wear allowances are provided on them. Okay? So let us say if it is a workshop gauge, there is a minimum size of go, maximum size of go plug. Minimum size of no go plug, maximum size of no go plug. Minimum size of no go ring, maximum size of no go ring. Minimum size of go ring, maximum size of go ring. If you give these dimensions, there is an answer. Okay, now you know what happened? Because workshop and inspection departments are having different gauges, so complications came. There are conflict between the two departments, and in small scale industries generally you try to avoid muda muri mura. Muda muri mura in English basically waste, strain and discrepancy. This is the discrepancy. It's a muri, nahi mura. Japanese mura means discrepancy. So this is mura. 3M. So you know ISO, International Organization for Standardization. ISO has made some recommendations later on. So third type of gauge is called ISO gauge or general purpose gauge. So you don't want to get into any mura conflict, then adopt ISO gauge. That is the third option. So everybody look at the word ISO gauge. ISO gauge is also called general purpose gauge. ISO full form is International Organization for Standardization. International Organization for Standardization, ISO. So ISO has made recommendation. According to ISO or general purpose gauge, you take go from the workshop and no go from the inspection. So 50% you, 50% you. Okay, have an agreement. Okay. So you take go from the workshop and no go from the inspection. So ISO gauge will be, this is your go. This is not go because allowance we have to provide on the go gauge now because we are taking from the workshop. This is go. This is no go. So in ISO gauge, on the go side, we are rejecting some good parts. We are rejecting some good parts. In not go side, we are accepting some bad parts.